Okay, are you guys able to see my screen? Are you able to see my screen, guys? Okay, today we will discuss about Docker. Okay, so what all things we cover in Docker is, first thing is Docker engine. What is Docker engine and how it works? And second thing is like images and image management. Third thing is networking in Docker. And fourth is storage and volumes. And fifth one is security. Okay, in Docker we'll be talking about these components. First thing is going to be Docker engine. Second thing is image and image management, networking, storage, volumes, security. So coming to Docker engine, like today I will start with Docker engine. Like what are the components we discussed with the Docker engine? Okay, so coming to Docker engine, first we'll be discussing on Docker architecture. And Docker installation and setup, and then Docker service configuration and all, and basic container operations, and restart policies and copying contents into the Docker. These kind of things we'll be discussing on. Okay, and let's start with the Docker architecture. Okay, coming to Docker architecture, how Docker works is like, see, Docker will have a component called Docker CLI. Okay, which uses REST API to communicate with the it uses a REST API to communicate with the Docker daemon. So coming to Docker daemon, like this is the latest Docker architecture. What I am talking is like Docker is following this architecture from version V 1.11. So in the Docker daemon, we'll be having three components. One is images, volumes, and then networks. Okay, these are the three components which we are currently having in the Docker daemon. And this Docker daemon communicates with the container D service. Container D. Okay, container D is something which is useful for managing containers. This is useful for managing the containers. And container D will manage containers by using something called container D shim. Container D shim. Okay, this is responsible to it acts as a mediator between the this container D component as well as the runc containers. Runc is responsible for running the container. Runc is nothing but run containers. So this runc means run containers. So container D is responsible for managing the containers, and container D shim is a mediator between the container and the mm, main part of the Docker daemon, which uses to manage the container. So container D manages containers using container D shim. And this runc component is responsible for running the containers. And coming to containers, right, each container is a isolated content environment, like each container is isolated. So in order to make it isolated, we'll be using something called lib container, which comes with the Docker itself. Okay, this lib container component uses kernel features. One is name groups and C groups. Okay, this lib container will be using two Linux kernel components, name group, namespaces, and C groups. Namespaces. Okay. So these namespaces are responsible for running the containers in a isolated environment. So basically this is the Docker architecture and this is the Docker flow. So when you install these Docker components, you need to have Docker CLI, which uses a REST API to communicate with the Docker daemon. And Docker daemon having these components such as images, volumes, and networks. And container D is the service which is responsible for managing the containers. And container D shim acts as a mediator between the run container and the container D. And these run containers, right? con- all the containers will get will be running using this run containers. So while running these containers, every container is isolated. So how they are being isolated? Because means it uses something called lib container. Lib container communicates with the kernel features such as namespaces and c groups, and it will make the each container isolated from each other. Okay, this is how the Docker architecture is. And let's see in Google for the Docker architecture diagram. These all are best diagrams. Mhm. Let's look into Docker website only. Okay. So the whatever architecture we discussed, right? This is all about the Docker engine. So when you look into this Docker engine, like before going to Docker, I need to say what is the difference between VMs and Dockers. Like why do we need a Docker? It's better I cover these things at first than going into this. If you look this particular diagram, right? See, before Docker comes into existence, how we will be hosting the applications is like we'll be having one infrastructure. On top of it, we'll be having a host OS, and on the host OS, by using a hypervisor, we'll be creating virtual machines. So virtual machines are something is just like the Windows machine what I am using. In the same way, we'll be using these particular virtual machines here. So whenever you create a machine or a server using this particular thing, you need to make sure your server is secured, your server is patched, and you will be installing multiple components within the server. And you won't be able to run multiple applications on the server. Why? Because each application has some dependent libraries. If you are running multiple applications on the same server, you need to make sure all the libraries, whichever you install on the server, are being supported. If it is not supported, what happens is the application has some dependency with some library. If you don't have that particular library installed, you won't be able to run the application. And if you are installing that particular library, it may conflict or it may cause issue with the other library, and that will impact other application from working. So these are some drawbacks using the VMs, like hosting the application in the VM. And one more thing is like this is one of the drawback or multiple drawbacks, like you need to maintain all the VMs, and you need to manage those VMs, you need to secure those VMs, you need to patch those VMs, and then you need to look into many other aspects like server hardening. These all things you need to take care. Okay, so because of this, what happens is, so the application go live time increases as it has multiple dependencies with the VMs, and it's hard to maintain multiple VMs as well. So to come out of this, we came up with some solution called Docker. Okay, so how Docker is like Docker also follows the same architecture like how we have, but on top of host OS, we'll be having something called Docker engine. Like we'll be installing a Docker engine. On top of Docker engine, we'll be running multiple containers. Containers is nothing but image of your OS with a minimum required libraries. It won't be having full libraries, like it is a minimal image version of the OS, like with the mandatory libraries. And if you want, you can install custom libraries within the image, and then you can add data related to your application, and then you can start the container. The advantage of running containers is you can spin up container in a fraction of seconds, and you don't need to worry about the libraries which are there on the host OS. Why? Because all the containers whatever you spin up, right, they are isolated from the OS. They runs with their own OS irrespective of the host OS. That is one advantage. And you can even, you are isolating the applications, so you won't be facing any issues with the application library conflicts or anything. So that is one of the major advantage of using Docker. But if you are using Docker, see, Docker is most preferable if you are using a microservice kind of a architecture, as containers is small and it's very fast to run, right? It's not a good idea to host a big application. So when I say microservices, what is meant by microservice? Microservice is something like, if you have a big application, we will be uh, distributing each functionality of an application in one container instead of rather hosting all the things on one server. So each functionality will be hosted on a separate container, and we integrate those things. The advantage of this, having this type of microservice architecture, is if one component goes down, only particular functionality of the application won't be available. Remaining all the parts of the application will be working as expected. Okay. Like, instead of this, if you're hosting on a VM with a big application, if there is some issue, it will brings down your entire application rather than a particular functionality. So these are multiple advantages we have using Docker. And if you, as it is a microservice based architecture and it is integrated with multiple components, right, we need to make sure the way we design the application is a stateless. You can even have a stateful applications, but yeah, it's preferred to use a stateless applications. Stateless applications means something which stores the state of the user initiated session, and based upon that state, it will be taking the action. So if you make the application stateless, irrespective of the user who logged in, based upon the logics we define and all, application will work as expected. Even stateful applications are also supported, but you need to have a medium where you will be storing your state and how do you retrieve the state. These all things you need to have it in the application. Okay, that is the major difference of you hosting the application in a virtual machine and hosting the application in a Docker. Any questions on this? Hello. Is everything clear, guys, in respect of VM and Docker? Yeah, I will tell in Telugu going forward. ఇంతవరకు క్లియర్ అయినా మీకు? Okay. So this is the Docker difference between the virtual machine and the Docker. ఇది మన డాకర్ కి వర్చువల్ మెషిన్ కి ఉన్న బేసిక్ డిఫరెన్సెస్. అండ్ కమింగ్ టు డాకర్ ఇంజన్, అండ్ దిస్ ఈస్ ద ఆర్కిటెక్చర్ ఆఫ్ ది డాకర్ ఇంజన్. దిస్ వన్ ఐ క్యాన్ రిప్రజెంట్ ఇన్ ఏ గుడ్ డయాగ్రామటికల్ వే యాజ్ వెల్. అంటే ఇది నేను ఒక డయాగ్రామటికల్ వేలో చూపించచ్చు మీకు, వన్ బై వన్. ఇదే ఫ్లో వచ్చేసి ఇలాగే ఉంటుంది, నేను సింపుల్ గా చూపిస్తున్నా మీకు. అండ్ దిస్ ఈస్ ద బేసిక్ ఫ్లో అన్నమాట. మీకు ఎలా ఈ డాకర్ ఇంజన్ వర్క్ అవుతుంది, ఏ కాంపోనెంట్స్ ఇన్వాల్వ్ అయి ఉన్నాయి, ఏ కాంపోనెంట్ లో ఏమొస్తాయి అన్నది ఇది. ఇది క్లియర్ అయినా మీకు డాకర్ ఇంజన్ ఆర్కిటెక్చర్? ఏమన్నా క్వశ్చన్స్ ఉన్నాయా? డాకర్ లో ఏంటంటే మీకు డాకర్ సిఎల్ఐ అని ఒక కాంపోనెంట్ ఉంటుంది. సిఎల్ఐ అంటే కమాండ్ లైన్ ఇంటర్ఫేస్. ఓకే, డాకర్ సిఎల్ఐ అంటే డాకర్ కమాండ్ లైన్ ఇంటర్ఫేస్. అదేం చేస్తుందంటే మీరు కమాండ్ లైన్ ఇంటర్ఫేస్ లో ఏం చేస్తారు, కమాండ్స్ టైప్ చేస్తారు. ఆ కమాండ్స్ టైప్ చేసినప్పుడు అవి డాకర్ డెమాన్ తో ఇంటరాక్ట్ అవుతాయి. దేని బేసిస్ లో ఇంటరాక్ట్ అవుతాయి, రెస్ట్ ఏపీఐ బేసిస్ లో ఇంటరాక్ట్ అవుతాయి. సో డాకర్ డెమాన్ లో మనకి ఏ కాంపోనెంట్స్ ఉంటాయి, ఇమేజెస్, వాల్యూమ్స్, నెట్వర్క్స్ ఇవి ఉంటాయి. సో వన్స్ ఈ డాకర్ డెమాన్ ఇవి కంట్రోల్ చేసేటప్పుడు మీకు డాకర్ డెమాన్ నుంచి కంటైనర్స్ కూడా క్రియేట్ చేయాలి. యాక్చువల్ గా ఇంతకు ముందు ఈ కంటైనర్ డి షిమ్, ఈ రన్స్ అన్ని పార్ట్ ఆఫ్ డాకర్ డెమాన్ ఉండేవి. కాకపోతే దాన్ని బయటికి తెచ్చేసారు, అన్ని ఒక దాంట్లో ఉండటం కన్నా లూజ్లీ కపుల్డ్ ఆర్కిటెక్చర్ అయితే బాగుంటుందని. సో దాని తర్వాత మనకి ఏమవుతుంది, ఈ డాకర్ డెమాన్ నుంచి కంటైనర్ డి సర్వీస్ అని ఒకటి ఉంటుంది. ఇదేం చేస్తుందంటే కంటైనర్స్ ని మేనేజ్ చేయడానికి యూజ్ అవుతుంది. అంటే మేనేజింగ్ అంటే ఏంటి, కంటైనర్ క్రియేట్ చేయటం, బేసికలీ ఇట్స్ ఎ కంటైనర్ లైఫ్ సైకిల్. ఓకే, లైఫ్ సైకిల్ అంటే ఏంటి, పుట్టినప్పటి నుంచి చచ్చిపోయినంత వరకు అన్నట్టు. అంటే కంటైనర్ క్రియేట్ అయినప్పటి నుంచి పోయినంత వరకు బేసికల్లీ. దాని తర్వాత ఈ కంటైనర్స్ ని ఎలా మేనేజ్ చేస్తుంది, అది మధ్యలో ఒక మీడియేటర్ ని వాడుతుంది. అది నథింగ్ బట్ కంటైనర్ డి షిమ్. ఆ కంటైనర్ డి షిమ్ యూస్ చేసి మీకు దాంతో కమ్యూనికేట్ అవుతుంది. చేస్తూ రన్ కంటైనర్స్ వచ్చేసి ఈ సర్వీస్ ఏం చేస్తుందంటే మీకు డాకర్ ని రన్ అయ్యేలాగా చేస్తుంది. వన్స్ ఇది మీకు డాకర్ కంటైనర్ రన్ అయ్యేటప్పుడు మీకు ఆ, ఇది ఇప్పుడు డాకర్ కంటైనర్ డైరెక్ట్ గా ఇలా రన్ కాదనమాట. దీనిలో ఇది లిబ్ కంటైనర్ అనే పర్టికులర్ కాంపోనెంట్ ని యూజ్ చేసుకుంటుంది. దిస్ ఈజ్ ఆల్సో పార్ట్ ఆఫ్ ఏ డాకర్ ఇంజిన్ అన్నమాట. ఈ లిబ్ కంటైనర్ ఏం చేస్తుందంటే కెర్నల్ కాంపోనెంట్స్ ఉన్నాయి, లైనక్స్ కెర్నల్ లో మనకు కొన్ని కాంపోనెంట్స్ ఉంటాయి, నేమ్ స్పేసెస్, సి గ్రూప్స్. అవి ఏం చేస్తాయి అంటే ప్రతి ప్రాసెస్ ని ఐసోలేట్ చేయటం, ఒకదానికి సంబంధం లేకుండా చేయటం, ఇవన్నీ చేస్తాయి. సో ఇప్పుడు డాకర్ లో మీకు కంటైనర్ క్రియేట్ అయినప్పుడు ఎవ్రీథింగ్ ఈస్ ఐసోలేటెడ్ అనమాట. ఓకే, so when these components are isolated components, how do you maintain is by using these kernel features. That is how this runc container runs the containers by isolating the environment. This is the Docker engine flow, architecture flow, like what components it is and how it interacts and how it functions. ఏ కాంపోనెంట్స్ యూజ్ చేసుకుంటుంది, ఎలా ఇంటరాక్ట్ అవుతుంది, ఎలా వర్క్ అవుతుంది అన్నది. ఇస్ ఇట్ క్లియర్? ఎనీ క్వశ్చన్స్? హలో మౌనిక?
Sir.
Not you, students. Okay, okay, fine. So you got the clarity between the Docker engine architecture and a typical VM, how we are using before, and a Docker, how it is. So you got the differences, right? Like what is the drawbacks of using VMs and what is the advantage of using VMs and how this Docker engine works. Okay, if it is clear, I will proceed with the next session. I'll proceed with the next topics. Okay. Okay, fine. Now let's go with the Docker installation. So in order to do this Docker installation, I will use a Linux machine. This is a RHEL 8, I guess. Let's see the version. Like cat etc red hat hyphen release will give you the Linux version. It's 8.4 UTPA. This 8.4 version name is UTPA. UTPA. Okay. So now this is done. Now coming to this installation. Installation can be done in three ways. Like both are same, but the way we both are same, the roots are different. That's it. First installation is using the repo. Repo is in a sense like in Linux, we'll be having something called M repo, satellite server, Ubuntu repo, like that, CentOS repo, and all. By using the repo, we install it. And the second thing is like you will download some binaries, like or else like you can make it as a installation from package. Okay, you will download some binaries and you will install it. And the third one is like we have something called convenience script, where the script is being provided by the Docker itself. and you can run this particular script and it will be performing its action. Okay, in this way we can install. So we can install Docker in these three ways. Okay, coming to the first way. Let me show you this convenience script first. We will install the Docker in the convenience way. I mean, with the repo. Okay. So, so how do we install Docker in the convenience script? Let me show it to you. Get.docker.com. If you type this particular URL, it give you one script. Okay. This is the script. If you run this particular script, it will take care of all the Docker installations. This script is written in a shell scripting. Okay, and it is using a shell called sh. And 1 second, I will be back in a minute. 1 second. Sorry, guys. Yeah, sorry guys, sorry for the interruption. So this is basically a shell script. What this shell script does is like, see in the Docker, you have something called stable, nightly, test, and edge. This is depreciated. So whichever version you want to install, you can install it. Basically, people prefer using a stable install, and it will look for a default channel value is stable. If you want, you can modify this environment to anything else. Out of this anything, you can set it up, and then it will be taking the downloaded repo is from this particular URL, and the repo name is this one, and then this shell script, and like these all are like case statements. Like you want to run this script as a dry run or else a mirror, like that. Dry run is something like it will just run the script, but it won't take any action. If you run it as a mirror, it will be running. And in mirror again, it has these things. Ali and China download. These all things. These are the options you can give. Okay. And then once you come to the next steps, it will be taking this particular version of your kernel, like what is the OS flavor, and based upon that it will set up the repo, and then it will install all the components. Okay, and this is not preferable if you want to install Docker on a production environment. If you want to install Docker on a production environment, you need to modify this script based on your requirement. Okay, this is the third way which we are talking, installing Docker using a convenience script. And coming to this binaries. So how do we install it using binaries? Is nothing but a packages. So here if you go download.docker.com, here it is showing three operating systems: Linux flavor, Mac, and Windows. Just click on Linux, in which flavor of Linux you are using. CentOS and 8.0 version, and x86-64 is our architecture, right? And then which package you want to download, stable, and then packages. You can download all the RPMs and you can install it. This is the second way of installing Docker, which is directly downloading the packages and installing it. Let's suppose if it is Windows, you will be having some sort of exe files and all, x86-64, and you need to download these zip files and extract, and you can run it. Okay, this is the way we install Docker in the second step. And then the third step, how we will be doing it, we'll be configuring the repo. That repo will be is of the same directory, same URL only, like download.docker.com only. And then we'll be adding the repo. So here what I do is, uh, first let me install mutils. Mutils, in mutils you will get one component called mconfig manager. So in order to use it, I need to install mutils. By default, it won't be available on a RHEL machine. We just need to download and install it. So I'm downloading now mutils and it gets installed in a while. So it is downloading and it is installed. So now what I do is, like, I will configure, see, before configuring, I will show these things. M repo list. It will show the list of repositories to which this particular RHEL server is configured. Here there is no Docker repo currently. Now let's configure the Docker repo. So how do we configure this one? M-config manager, and then you have a command called -add -repo and the repo URL. Repo URL will be the same thing like download.docker.com slash before where we went Linux, CentOS and all we went here, right? Linux, CentOS in the same way we give. Okay, Linux, CentOS, and then docker-ce.io. So what do you think about Docker CE? See, Docker comes with two versions. Docker comes with two versions. Okay, first one is community edition, and the second one is enterprise edition. So community edition is a freeware and we should use it for non-business purposes, and we won't be using it for business purposes and all. In order to use it for a business purpose, we need to have a Docker Enterprise Edition installed. Enterprise Edition has lot of features. Like coming to the differences in features, right? Let me show you this thing. So if you go here and type this particular Docker, see in the enterprise edition you will get something called UCP, universal control plane, and many other components you will be getting. You'll be getting a Docker trusted repository registry where you will be having a private image repository and all like that. There are multiple components. Even you can this is not a good URL to check. You can check it directly from the Docker website itself. Okay, when you have time you just go and check these components. Okay, in enterprise we have basic, standard and advanced. In the advanced, what are the features we have? In standard we have LDAP with AD integration, and the RBAC will say role based access control. These all things will be there. Okay, and community edition is a new name for the free Docker products. Like you can use anything. Like when we talk about enterprise edition, you need to purchase it. Community edition is a freeware and the features vary. Like in free they won't provide all the features. When you go with enterprise edition you will see all the features of the Docker. So currently what we are installing is a community edition. The components will be the same whatever we install, but these component features are less compared to the enterprise edition. So now I am adding this particular repo. When I do this m repo list, right now it is showing me a new repo. It should show that is nothing but this docker-ce.io, right? But there is one mistake in adding this. I should not use .io. .repo I need to use. Repos will be having a extension of .repo. I used the .io by mistake. When you type this m repo list, you got the repo name docker ce stable. So by default stable gets configured, and now this particular Docker repo is configured. So as we configure this repo, now we'll be able to download the Docker components. So how do we download this? M install docker-cl community edition we are using, right? So when we use this community edition, we need to pass -ce. Docker-ce you need to use. This is a Docker engine, and docker-ce-cli we will be using. And one more thing is containerd.io. As I showed you, right, that containerd components in the architecture. This is the Docker engine. Docker CLI. This is Docker daemon, Docker CLI, and containerd components. And when I type -y, it's like approving the install, or else it will ask us to approve it. So since I configured a wrong repo before, it is picking up these things. Basically, whenever you tc m.repos.ds, whatever repo you configure, right, it comes into this particular directory. So I'm removing this one. There are commands to do it also. I'm doing it in a hard way. Now I remove this. Now let me try installing these components, Docker components. So these all are dependencies, all the dependencies, everything it will download and it will configure each and every component of the Docker. So this is how Docker gets downloaded and it gets installed. If you do manually, right, you need to make sure all these components are there and all. That's the reason I didn't went with the manual install. Instead, I came with this install. Yes, you can use wget command to download in Linux, but we are not downloading anything. We are configuring the repo and getting the packages from the repo. If you are not sure about Linux, please read this Linux. What is yum repository? What is satellite server? How yum repository communicates with the satellite server? How it downloads the packages and how it will install? And what is the advantage of using these things? These all things will be there. You can even use wget command as well as curl command also to download the components on the Linux. Okay, but we are installing these things from a repository, some packaging server. Yum is nothing but a repository where we will have packages related to Linux or any Linux distribution. And in here you use yum in Ubuntu, apt and get, like that. It depends upon the flavor of the operating system we use. Even CentOS uses yum, and even in RHEL late you can even use DNF as well. Instead of yum, you can use DNF as well. It also does the same thing. Okay, Hamad, is your question clear? Hamad, can you please respond? Okay, thanks, Hamad. Okay, this is how we install Docker. So when I install Docker, how can I start the Docker? We use something called systemctl, or else you can use something called service. Service Docker start. See, when I run this one, it will redirect to systemctl only. It redirected to systemctl Docker service. So how do you check whether Docker is running or not? Systemctl status Docker. Okay. So now if you say the Docker is running here, status is running. Now when I type this Docker PS, okay, and container ls-a, it will display list of all running containers. Currently, we don't have any container running. That's the reason it is showing blank. All right. So if you guys observe, this Docker is listening on something called docker.sock. What is this docker.sock and how it works? Let's talk about this. See, by default, when you install this Docker, right, what it does is like it will use something called Unix socket. Okay, Unix socket, which is nothing but a Docker socket, like docker.sock you seen right there. This is nothing but a Unix socket. So what does it mean? Like when it is running on this socket, what happens exactly is this is the inter-process communication. That means it will useful to communicate within the process, like it will allows one process to communicate with the other process. So here if I am doing this Docker PS and all, it will allows the communication within the process but not within the network. Let's suppose you have Docker daemon installed on this machine, and if you want to control this Docker daemon from other machine, like in order to control this Docker daemon, you just need to have a Docker CLI. On the other machine, you can install this Docker CLI, and when you try to communicate to this particular Docker I mean to this particular server on which this Docker is installed. By running this Docker PS and all, you won't be able to communicate it directly when it is configured with a unique socket, nothing but a Docker socket, as it is the inter-process communication, as it is used for a inter-process communication. Okay, that is what unique socket is. So I will show you the scenario like export. See, basically, how people communicate is export docker underscore host equal to. So, to which host you want to communicate? 172.31.81.107. All right. And here the port is 23. Docker will be using two ports. One is secure port, and the other is non-secure port. So I'm giving 2375. 2375 means non-secure port. So if I try to run this Docker PS, it's unable to communicate. Why? Because this particular Docker daemon is not listening on any IP socket or anything. It's just listening on a unique socket, which is the purpose of unique socket is like it's an inter-process communication. It will allow to communicate between the process, not via network. So if I am trying to communicate to the Docker using this particular thing, it is not working. So how can you make this work? I'm unsetting this thing and Docker PS I'm running. Again, it will work. So 2375 is non-secure port. 2376 is secure port. Okay. So now I will show you how to run these things. How to run it in a TCP socket mode so that we'll be able to communicate with the Docker daemon via network from other machines as well. So in order to do that, first let me show you how to run this Docker in a foreground process as well. We don't need to run compulsory in the foreground process, just for your understanding, I'm sure. Okay. Now the Docker is stopped. If I type Docker PS, see what it is saying is when you stop and but it can still be activated by Docker socket. As I run this Docker PS, it got reactivated again. So if you want to see like this systemctl status Docker, now the Docker is in stop state. All right. So how do we run this Docker daemon in a foreground process? Let me show you those things. 1 second, guys. I'm adjusting my position. Yeah. So whatever commands we run using systemctl or service, Docker runs in a background process. Now we are running Docker in a first. Before that, I will now we'll be running the Docker in a foreground process. To run the Docker in a foreground process, we use the command called docker d. And you start this Docker is running. So if you see here, this log is informative log. It's not a debug log. And what if you want to run this in a debug log? Hyphen debug, if you give, it will run in a debug log. See, if you see these all things, right? Images, all the APIs are being exposed so that we can communicate with the Docker. So these are the APIs being supported by Docker. So these all things. And here, if you see at the end, it is be getting run on something called Docker sock, docker.sock, which is nothing but a Unix socket. So I'm opening a dual session on the same VM so that we will communicate with the TCP port as well. I will show you. So how can we do it? Docker D hyphen, let me run it in debug mode. So here you want to run it in a TCP mode, right? So you will pass the host and then TCP and then like HTTP URL you will be giving and then the IP address 172.31.81.107. 107. This is the server IP. I can see it from the top here. By seeing it, looking it here, I am writing. Okay, I didn't remember the IP address. By looking here, I am writing the IP. and then 2375 port. So now if you see here, now Docker daemon is getting started via TCP socket now. If you see here, now the API is getting listened on a TCP socket. So let's do the same thing. Like I will export Docker host on the other machine. Same machine it is. Since it is a foreground process, I opened a other session. We can make it as background also. Those things also I will cover. Mm, Export Docker underscore host equal to this particular IP. So here we want to communicate it, right? And now if I type Docker PS, it's getting communicated, right? Before when I give this one, it is not communicating. Why? Because see here you can see Docker CLI communicates with the REST API. When I do this Docker PS, what it is doing? It is doing a get call of this containers version v1.4.1 and this one. Okay, and if I do this Docker container ls, you see what it is coming. It is doing the same get call. Both commands refers to same thing. Okay, this is how it is happening. So let me switch it back to Unix socket. So even we didn't configure any configuration files, I'm starting this Docker directly. So here, if you see, even in this particular log also, you can see whether how the Docker got started up. Okay. See, now it's ran back in the Unix socket. If I run this Docker PS now, it won't work. Why? Because it is not running on a Unix socket. In order to make it work, since it is same host, it will work. If it is the other host, it won't work. I am unsetting this particular environment variable, and then okay, something happened here. Still, it is unable to communicate. So what happened is Docker process is dizzy, like it is not killed properly. So what I will do is let me reboot the server once. Since I ran it in foreground and I killed it randomly, right? We have some file descriptor open, and because of that, it is blocking this particular thing. Even the process is running. This is routine issues which we get. I'm just rebooting the server. Once it is rebooted, everything gets fixed. Any questions till here, guys? Is everything clear for you? Or do you have any questions here? Please feel free to ask questions. Server is not it up. Yeah, these commands you can get in internet. It's not a big deal. Go to this Docker commands and you type in Google, you will get. And let me show you, like if you don't know the commands, how can we get these commands? Let me, once this hour is up, I will show you. Mm, okay, now this hour is up. Okay, Docker PS. Mm, okay, now these things are working. No, you can even use VM. Docker works on top of VM only. It's not like we should not use VM, but if you use VM, what happens is you need to manage the VMs, and you need to, whenever you are installing some package related to the application, and it may conflicts with the existing library of the VM. If you are using VM, we need to patch the server on regular basis. Those patchings will impact your application, and at the same time, you need to make sure whenever you are hardening the VM or hardening the server OS, you need to check all the compatibilities with your application and all. Here, as the when you are using multiple VMs, right? The VMs grows, the capacity of the VM grows, the way, like the amount of VMs which you need to manage will increase like anything, and at the same time you need to look into the dependencies as well. So these all are some big headaches for us. So to overcome these headaches, you will be having Docker installed on 3 or 4 machines, and you can have multiple containers running on top of it, and you don't need to worry about the patches what we install on the VM. Why? Because that one is separated from the Docker container, and Docker doesn't r- really depend on the VM packages as well. It just depends on the Docker daemon and all. That's it. That's the main reason why people use nowadays these Dockers, serverless applications, containers, and all. Okay, so that you can have a microservice kind of a architecture, like a like before on the VMs, people used to use monolithic applications. Where what is meant by monolithic? Any idea, guys? What is meant by monolithic applications? Monolithic is not just interconnected. Monolith Docker is for microservices. Okay,